Internet Protocol is a best-effort connectionless protocol which is used to connect networks by routing and addressing each packet. Back in 1998, we see this Request for Comment 2401 that provided a framework for what we know of today as IPsec, a security architecture for the Internet Protocol. It has since been updated to RFC 4301, but it has many of the same beginnings of the original RFC. IPsec is a framework for securing IP communications and is designed to provide security for IP version 4 and IP version 6. IPsec can both encrypt and authenticate each IP packet of a session between hosts or networks across the LAN and the Internet. IPsec can protect a much wider range of applications than SSL, and no special training is required when using IPsec. We can add IPsec to IP version 4 or IP version 6 by using additional headers. If we take a look at our diagram on security mechanisms in the TCP/IP stack, we see that IPsec provides security at the network layer and can protect the higher layer protocols. IPsec is not a single protocol. It is a framework that provides a set of security processes which have 4 main components. The security protocols. They include the authentication header, which provides support for data integrity and authentication of IP packets, and the encapsulating security payload. This is a combination encryption and authentication protocol. Key management. Key management can either be manual in a small environment or a much wider application which is done automatically using the Internet Key Exchange, or IKE. And security associations. Each security association is created and provides the attributes that are necessary for the encapsulating security protocol or authentication header processes. And the algorithms. The algorithms which are important to provide the following: key exchange, integrity, encryption, and authentication. IPsec was designed to provide flexibility in how it is set up and what level of security is required. A security association or relation created between 2 entities describes how the entities are set up, the security protocols, algorithms, and keys required for the services requested. IPsec can be used to protect one or more paths that include host to host, from one host to another, gateway to gateway, between pairs of routers using IPsec with a virtual private network, gateway to host, an outside host to the gateway. Services IPsec can provide include access control, integrity, authentication, preventing replay attacks, and confidentiality. But take a look at this illustration. Keep in mind, it is not a single protocol, but a framework. Over on the left-hand side, we see the encapsulating security payload protocol, which includes encryption algorithms such as DES or AES. On the right, we see the authentication header protocol, which includes authentication algorithms such as MD5 or SHA. But encompassing all of those things is the key management. When setting up IPsec, which can provide so much, careful consideration of where and how the IPsec framework is set up must be considered, as more advanced configuration might be needed, as in the case of implementing IPsec in network address translation environments and providing support for IP multicast.